The kit comes in a very nice box. You get 10 meters of PLA to play with, acrylic bed, some thick sheets of acrylic covered in protective paper, a couple of screwdrivers and some Allen keys, a USB cable with a power brick, 5 amp supply, some connectors for the stepper motors, some pulleys and wedges, some nuts and bolts and bits and pieces, cable tidy, some more acrylic plates for the stepper motor mounting, among other things. And this is the extruder unit with a fan in the end there. This is the main electronics board, and this is the front display with some buttons on there to allow you to control it. The 3 main aluminium extrusions. This is the lead screw to implement the Z axis, the up and down axis. It's another one of the extrusions there. And this is the USB stick-on, which is the instruction manual, assembly manual and so on. These are really nice. These are the T-nuts. Oops. Well, that's what it is at the end of stage 1. Next thing is this motor assembly. Just take the paper off the acrylic plate, fit the limit switch. Nuts need pliers on the back to get a decent grip, and there's some slop in the position of this, so I might need to adjust this. That's that done. And we're putting it on the system. There. There it is. This is what they're calling the bed frame. A couple of areas of concern. One is these wheels are just tightened on to the bolts with the spacers with nuts on the back, so you're just pinching everything together. A couple of the wheels are still free turning, but this one is less so, and actually none of them are really free turning. They won't go. They won't move after you stop pushing them, and they're not the same tightness. The other thing is it's not clear from the diagram which way this belt goes round, but I'm hoping that the absence of teeth appearing here means that the teeth should be underneath. We shall see. Oh well, those 3 wheels engage on this extrusion like that, and the belt goes in the slot here and goes around the pulley. So I'm just I've slackened this pulley off, and I've adjusted its height so it runs between this slot here, not out as it was here where it's binding. Somewhat worryingly, you just pull this tight now and tension it with another cable tie. Something else I've just noticed, I don't know if you can see that. On the top side of the extrusion, the belt is touching, and that's because the pulley is not correctly spaced away from its mounting plate. The pulley needs to come this way a bit further. Couple of ways to fix that. I can file away this extrusion there to stop it binding, or find another washer to put a slightly bigger spacer in there. I'll do the spacer thing, I think. So what I've done is put an additional washer on the plate on the far side of the nut, and I believe that has solved this problem. Okay, I have completed the fitting of this axis. Another potential gotcha, I was tensioning this and was getting ready to finalize things before, and then I realized that this one had drifted out while I was messing around with it earlier on and was no longer sitting snug on the bed. So make sure that that's tight all the way around, and then make sure that that's tight. There's no indication of how tight you need it, how tight it should be, and it's difficult to believe these cable ties will maintain their grip constantly, or their position, throughout many prints. We'll see. This is the completed assembly. This hole here is used so that you can tighten the screw, the head on this bolt, and it's important that there's on one side there's a recess. This side does not have a recess. The other side does have a recess, and it's only that recess which allows you to sit this plate on here without the head of the screw impeding that. None of which is mentioned in the instructions. Yay. And so we should be able to sit this on there. Oh yeah. Right, so I've put the motor on. Unfortunately, there are only 2 of the 4 bolts required. They're M3 8mm bolts. They're not in the pack, so I guess I'll have to find some from somewhere else. The extruder unit comes ready built and just slides onto the beam, so let's do that now. Well, this is a bit of a problem. The extruder doesn't fit. The top and the bottom rollers are nice and snug, but the second top roller, the third roller, is well, you can see basically the gap between the 3 rollers is smaller than the width of the beam. Well, I've eventually got it on by careful use of a lot of force, and it does move up and down. These wheels are rubber, and so you just take the flex up in those. So I guess I've got past that. But it says carefully insert, like it's a drop down thing, but in fact you need a lot of force to get it on. Another little annoyance here. Fit the limit switch, it says, so you do, and then attach it to the beam, which means putting that screw through there, which you can't do because the cable on the limit switch is blocking the hole. So I'll have to take the limit switch off, then put the bolt through, then put the limit switch back on. It's just pointlessly pissy. Anyone who's assembled this will have gone through this, and they know you've got to do that. Why not write it in the instructions? This x-axis is very tight. Some of that is because the these rollers are very close together, and you have to compress the rubber to get them in, as I mentioned. But look, focus, you fuck. There you go. See it binding on here? So this is another case where I'll need to insert a washer in here because the spacer is not correct. Okay, I've added the other spacer. It's that washer in there, and it's fixed the problem, sort of. Focus, you fuck. It really does work every time. So the belt is no longer binding on the extrusion, but I have to say it hasn't made a bunch of difference to how easily the extruder moves on this rail. It's very hard to move, and I don't know if we're going to burn something out when we try to run it, but I don't really see what I can do for the time being anyway. We need 3mm, which is this width, and they are okay in terms of width, but we want 8mm, and these are 20mm. So these will fit in the motor, but they're too long. And there are no 3 by 8mm screws left. So I'll have to use some of my own. This motor is meant to be attached to this column, with these T-nuts and this motor bushing like this. But as you can see, that bends the shaft quite a lot, and the shaft is attached to this bush here onto a metal frame which is completely located on the vertical shaft, so there's no room for allowing that to move. If I pick up the gantry, you can see where the shaft would settle for almost zero movement, and it's nowhere near where the bush motor bushing would locate it. It's a good, what's that, 5 or 6 millimeters away from the column there. Now it could be that the rod's bent, and that if I change this, just turn it round a bit, halfway around, it'll settle in a different place, but no, not really. So the question is, do I want to force it in? I actually can't. Do I want to do that, which will cause it to bind up, or do I want to allow it to settle where it wants to? I'm inclined actually to put some double-sided tape on the bed here, and for now stick it to that. I think that's what I'm going to do, especially given that one of the T-nuts is missing, so I can't put 2 on. Later on I can put in a longer nut and a spacer here. Oh, maybe that's what I should do. It'd be a more positive way to fix it. Yeah, I'll look at the spacer option, see what I can do. We're taking a leaf from TronXY's own design excellence methodology. What I'm going to do, can you see that, is use one nut as the spacer here. I'll put longer bolts in, and I'll have to make the equivalent of a T-nut by using a nut and a washer for the other one, or even not bothering. Okay, so I've jammed a, let's get some focus, you fuck, thank you. I've jammed a nut down the back on the left one, and I've used the lock nut we've got on the right one, and it's good and tight. I'm not too worried. It's not, oh, I'll finish it, I'll make a crossbar, I'll make a proper piece, or even redesign the motor bush and make it in aluminium. But anyway, for now that'll do us. And if we check the fit, I'll just drop the spindle. It's pretty much perfect. Job done. Okay, this is the extruder clip assembly, and it's a bit wobbly, as you can see. And the reason for that, FYF, that's it. I've discovered you can say the acronym instead of the actual thing. The reason for that is that this clip relies on being flexible, because you can't pinch this down too tight because the bolt's too long. That ensures that you can't pinch this off and have it too tight to move. The downside is it's not sitting down because the bolt's too long, so there's this wobble. I don't know whether that is a problem or not. I guess we'll find out. Putting the handle on, the two bolts which were supplied in the same pack as the handle, this one and this one, are not 12mm, they're 20mm, so consequently these can't be tightened down on there. That's it, so they don't work. Glaring error. Morons. Substituted some of my own 4mm bolts. These were, I think, 8mm or 10mm. Problem solved. Okay, I've got to attach the Z-axis limit switch to this bracket and then attach the bracket to the column. Use, it says, the there it is, select the limit switch, secure the limit switch, 2 pieces M2 10mm screws. The only M2 screws are bolts. It says screws, it means bolts. I've got these, and they are about 8mm long, and they won't go through that and out the other side of the limit switch and allow you to put a nut on. They're not long enough. End of. I have to use some of my own. You know, what was their plan? Let's put some screws in that can't work. That'll cheer up the customers. Well, that's done it. They're much too long Doesn't matter, it'll be hidden out of the way. Gets me over that hurdle. And there is the limit switch installed. Well, the next step is to build the bed, and this is part of that. But the bed mounts on this plate here on the x-axis. But look, I don't see how this can possibly ever print anything accurately unless it relies on gravity and certain limitations in the way loads are applied, so that these massive instabilities don't somehow make a difference, don't count, don't matter. Where are they coming from? Well, it's the spacing of these wheels. The spacing on the wheels on this axis, the y-axis, is such that this is a very tight fit, perhaps too tight. The spacing of the wheels on this plate are such that it's an incredibly loose fit, to the point of being, I mean, just dreadful. I don't know. I mean, to fix this, I would need to make a new base plate here with the distance between these two and the one underneath that pinches against it would have to be slightly smaller. I could imagine making some kind of an offset cam arrangement so that that would be adjustable. But do I complete the build? I think I'll complete the build like this and see what happens, and then tackle any problems if and when they arise. So the bed's now fitted. It sits on 4 spring bolts. There's some knurled adjusters there, so you can level the bed even though the supporting platform underneath may not be level, which is all very well, but you know, it's still doing this. I can't see how this can ever be okay. Unless, as I say, gravity means it doesn't matter. We'll see. Well, the first part of making the electronics box is getting the paper off of all these plates. I don't know why it's got to be so miserable, but it's really grim to get those off, and that just took me about 20 minutes. It's a minor point, but it's a point. Anyway, it starts with the bottom plate, which we've got to attach the electronics board to. Looks pretty nice. Can't see any obvious reasons to be concerned. Got to use some offsets to put it on the bottom plate. Just 4 bolts through the bottom and the plastic spacers. Sit the board on top and nuts on to hold it down. The sides are fitted, attached in an unusual way. There's a, get rid of the glare. There's a nut and a bolt, and the nut sits in a recess in the side of the, a notch in the acrylic sheet. Bit unusual. Not sure if it's unsightly or quirky and charming. Anyway, it works. Same thing for the front panel, attached in the same way. This is the LCD display panel. Buttons here. Well, now the front panel's on. Same deal with those captive nut and bolt attachments. I think the easiest way to get good access to the board is to leave the back off, fit all the cabling and even test it, and then put the back on and the top on. So that's what I'm going to do. So far so good, but you've got to take the front off as well because you need access in here. So the instructions tell you to assemble it and then wire it. Reality tells you you have to wire it and then assemble it. Not the end of the world, but wasted time and utterly stupid. Why would you write instructions like that? Another reason you need to strip it right down is because you need to read the board, or it'd be good to read the board. Power, hotbed, hot end, fan and so on. You can't read those unless you've taken it apart. So power goes in next. This is a really chunky cable, which is good. The power supply is 5 amp, 5 volt. So that's a good piece of wire for a 5 amp supply. Well, the wiring diagram is colour coded and fairly idiot proof. It's easy to lose track of which is X, Y and Z, but I wrote on the motors in the end. And when you get all that done, it's one hell of a mess, and it all goes into the box like this. But I'll actually, I don't know if I think I'll put the box together, but not put the cable tidy around it. There's one of these things where you can put all the cables inside it and make a much neater job, but we'll see whether the damn thing works or not before we do that. Well, the time has come to power it on. So we've got the adapter plugged in, the red light's on. I will plug it in the back. See what happens. It's a little bit pokey. Oh. The display is booting. Don't know if you can see that. Printer ready. Nothing moves. Ooh! Oh my word. Home all. So the right button here is select. Let me move that a bit so you can see it better. The Z-axis is the only lead screw axis, and that's sensible because you get a lot of precision but not a lot of speed. But on the Z-axis you don't need a lot of speed, it's only ever moving one layer at a time. Oh dear, that's got to stop. So it's stopped before it hit the bottom stop there and started storing. I can see why. The limit switch is in the wrong place. I need to look into that. But right now it's lunchtime. Here's the limit switch which wasn't being triggered. And the reason is that before it can trigger that, the motor here sits on the bed. So clearly that's not acceptable. So what I'll do is twist the motor, the Z-axis motor, till that just clears the bed. Oh, that's the wrong way. There. And now I'll move the limit switch up so that, just slacken this nut off and slide the thing up, so that the switch is on before it hits that. Right, I've adjusted the Z-axis limit switch, so we'll go again. Home all. Still not homing properly. Right, the mistake I made is that only when the X and Y are home, the nozzle is actually off the bed, so you have to zero it over here. It's all done around the back, don't worry your pretty little head about it, but we'll go again. An on-off switch would be really nice. I'll fit one. Home all. Now that noise it's making there is going up and down, it's not stalled. Right, it's home all. This platter being so loose is ridiculous. I can't really go any further with that, so I'm going to have to take it off and see what I can do to reduce the distance between the opposite rollers and pinch this tighter. So once again, the problem is the beam fits between here, and the distance between these is too large and it allows all that rattle. That's what we're going to try and fix. Well, that's really good news and really depressing. Oh, Jesus. All I did was tighten these nuts up, these bolts up, and now it's really good. Jesus Christ. My idiocy never ceases to amaze me. But it's all back together, and you know, it's not perfect, but it's not ridiculous either. And I'm feeling good about that. Yeah, I tightened the two outside ones. There's one inside there which you can't get to, and it's that one that I left loose stupidly, and that's what was causing the problem. Job done. Well, I'm preparing to do a test print, and it's preheating. And when it gets to 190, I'll feed in the PLA, and then we'll see what we'll see. In fact, it's not getting to 190, it's stopping at 189.6 and it's oscillating around there. I think that's probably good enough. So we'll feed in the PLA now. It's weird stuff. But anyway, here we go. Supposed to go through here and feed it down the Teflon tube until it reaches the extruder head, which I guess you know by feel. That seems to be there now. Okay, I've set offline printing and I'm about to select the file, the G-code file. I've gone down a little bit now, 109.4, here it goes. Wow. And there it is. What is it doing? Making a mess. Yeah, it's just making a mess. It's dragging it off as soon as it's putting it down. I'll just leave it going for a little while, see what happens. Oh, it's making a flat base. Very, very thin. 3% complete. Finished. Finished. Wow. Here's a close-up look at the part. This was my first experience with a 3D printer and the first time I'd held a 3D printed object or seen it close up. They are remarkable. What has to be done to make it is remarkable. The filaments, there are so many of them and they're so accurately positioned. The edges are smooth and regular. With this colour filament you can see the internal structure of the thing, the honeycomb there. It's just incredible, and it speaks well of the printer because, you know, if this printer can do that stuff, then it's got some core competencies. So a few problems with the build, let's briefly go through them. I didn't mention this earlier, but the reason the printer's sitting on a foam sheet is because the base plate is held on with some round-headed bolts, which of course stick out the bottom of the base, so it rocks, and it also scratched my desk. Guys, I just don't understand it. How could you think that might be okay? Next up, as we saw in the video, both of the drive belts don't quite clear their extrusions. I had to add extra spacers. Instructions on building the X carriage were dismal and guarantee that people are going to waste quite a bit of time before they get it fitted correctly. The whole nuts and bolts thing was a lottery, bits missing, wrong size bits, and many bits left over at the end that were never used. The extruder carriage is a very worryingly tight fit on its beam, and there's nothing in the manual to suggest that that might be normal. Attaching the limit switches can't be done in the way indicated, you have to do it the other way around. And I guess it's also worth pointing out there was no clarification on how to correctly locate the Z-axis limit switch. The Z-axis motor bush misaligns the motor with the lead screw. Again, how could that have been okay ever? In the area of wiring up, the instructions are wrong. You have to wire up and then assemble the control box, not vice versa. And finally, although this wasn't mentioned in the video, the build plate sits on the build platform where screws stand proud of the surface, and since the plate is thin acrylic and is held on with bulldog clips, it's a nightmare. It's not flat, it's not level, and it's not stable. I had to recess the holes to allow the countersunk screws to go below the surface, then things were fine. Having said all of that, I paid £155 plus £18 import duty to have a 3D printer delivered in kit form, which arrived in just over a week, and it seems on the basis of just this one test sample that it is a competent machine. So I'm looking forward to exploring it further, and I'll be updating this channel with the results of my experiments, so if you're interested in those, you might want to subscribe. Anyway, a bit of a long one. Hope you enjoyed it. Comments as always welcome. Yeah, thanks for watching.